Welcome back again, my dear students. Continuing with section 1.8 of your geometry textbook, perimeter, circumference, and area. We are continuing with the objectives related to the second objective, which is find the area of basic shape. In this occasion, we are working with an irregular shape. Finding areas of irregular shape, problem 6, page 63 of your textbook, geometry textbook. Well, let's analyze the illustration that we have here first. First of all, in this illustration here, we see irregular shape. An irregular shape that really, if you analyze it, is formed or made up of different squares. I can see a square here. I can see a square here. I see another one here. I see another one here, and I see another one here. So I see basically 1, 2, 3, 4, 5, 6 squares. That if we take another closer look, because we have to analyze the illustration first. First of all, that's the first thing we have to do with irregular shapes. Analyze. Another clue that it's giving us, that the problem is giving us, is that it's telling us that this space here, right here, measures 3 centimeters. That means this square measures 3 centimeters, and then it's pointing at 3 centimeters here, and then a little line here. This means that this side measure 3 centimeters, and then you see the same symbol on this side right here, and then you see it again here. So that is telling me that this space here measures 3 centimeters, this space here measures 3 centimeters, this one here measures 3, this one here measures 3, and this one here measures 3. And it is also telling me now that on this side it measures 9 centimeters, and then I have a different symbol with like 2 little lines. This is indicating me that this side right here, all the length, measures 9 centimeters, and then we have the same exact symbol here with no number, but this is indicating me that this side also measures what? 9 centimeters. So these are things that you have to look at very closely. You have to look for any clues that the geometric figure is giving you, and you also have to look at any clues that you can get out of the figures and how you can decompose into smaller parts like we did here before. Okay, now considering what I just explained, we can see here then that this square is a square that has all sides measuring 3 centimeters, that this one here is composed of basically 2 squares that measure each one 3 centimeters in base and in height. So combined together we will have a larger square that measures 6 here, as you can see indicating right here the combination. And then we have then another one that is basically composed of 3 squares, right? One here, and one here. So the base is a combination of 3 plus 3 plus 3, which equals 9. And the height then is only 3 centimeters, as indicated by the symbol that I previously explained right here. So what are we supposed to do in this problem? One way is decompose the irregular shape into all the possible regular shapes that we can identify, and the clues that we can get out of the symbols on the illustration. Just as we did here, we have then 3 areas: the area A1, the area A2, and the area for A3. Let's now analyze here and obtain the first area, area 1. Area, we know the formula is base times height. So the base of the first rectangle, as we indicated here, is 3. So the base here will be 3 centimeters times, we know that the height of this first square right here is also what? 3 centimeters, a perfect square. So that will be 3 centimeters right here. So 3 times 3, 9, and then the unit, one dimension multiply, they add up to make 2 dimension, and which match up with area, which is 2 dimensions, as we explained many times. So here we will have then 9 square centimeters for area 1. For area 2, base times height, we will have then, analyzing this decomposition of the illustration, we have that the base for this one will be 6, which makes sense because it's a combination of two squares. So this one was 1 here, and basically we have 2, so that'll be 3 plus 3, that makes 6. So the base for this area number 2 will be 6 centimeters times the height, which is the same, of 3 centimeters. Here when we multiply, 3 times 6 is 18, and then 1 dimension times 1 dimension, that makes 2 dimensions. So we will have that for area 2, we have 18 centimeters. And for area 3, we have the same, base times height, but in this one, taking a look close here, we have 1, 2, 3 squares of a base of 3 each one. So that will mean 3 and 3 and 3, that's 9, which is the base that we see here. So in this one, the base would be 9 centimeters, while the height remains the same, being 3 centimeters. When we multiply this now, we have 27, and 1 dimension, as we explained before, 1 dimension times 1 dimension makes 2 dimensions. And so we have that the area for the third figure is what? 27. Because what we just did was calculating each area independently, but this is one figure. This is in real only one figure, as we see here. But what we did was calculating each area independently of this irregular figure. So we have now to give the total area. So the total area, let's call it total with a lower with a T here for total. We will have that will be the addition of area 1 in this case, area 2, and area 3, which would be then 9 centimeters plus 18 centimeters plus 27 centimeters square. All of these with unit square. So then we add up these together, and we will end up having what? 54 square centimeters. Okay, so that is the solution for the problem on page 63, problem number 6. Thank you for your attention. Remember to practice. Take care and see you in class. Bye.